I have a friend with me here today, and he's a pixie frog. All right, so frogs are obviously amphibians. They do drink water, but they can also soak it in through their skin. His name is Henry VIII. Isn't he adorable? Definitely. All right, so you might know the life cycle of a frog or a toad. So if you do, you can follow along with me. The mama frog lays her eggs in a body of water, a river or a stream, something like that. Those eggs hatch and they look like weird little fish. They're called tadpoles. And they can breathe underwater because they have gills like a fish. Well, over time, they develop arms and legs, lose their tail, and they grow lungs like we have. So if Henry VIII goes underwater, he has to come back up for air because he doesn't have gills anymore. They also have built-in swim goggles, which is amazing. It's called a nictitating membrane, and it actually covers their eye each time they go underwater. Now, he is a carnivore. He does eat insects, but he can also eat small rodents too. Now, frogs have big, strong back legs that allow them to jump really far. So they can spring forward if they're afraid or they're hunting. It's an amazing ability. So we're going to do some experiments on forces in motion, in particular energy, kinetic energy and potential energy. Jumping frogs have an iliosacral joint in their pelvis that works like a hinge when they engage in jumping. It allows them to sit comfortably bent over in a crouched position and to straighten their backs completely when jumping. It puts all sorts of power in their leap. When a frog is sitting, that's potential energy. As he jumps, that energy is transferred or changed to kinetic energy, or energy in motion. Let's make a ping pong popper. It's a perfect way to convert potential energy to kinetic energy, and you can make it with some really easy to find materials. First thing I have is a plastic cup. This is one of the short ones. I believe it's a 10 ounce. I have duct tape, which is always an important material to have. I have a balloon, a pair of scissors, and a ping pong ball. Now don't worry if you don't have a ping pong ball. You could use something else, like a marshmallow or a goldfish cracker, maybe a piece of cereal. You can get creative with it. All right, so first thing we need to do is we need to cut the bottom out of our plastic cup. Now, this could get a little dicey, so you may need some adult help for this. I'll show you what I'm going to do to take the bottom of my plastic cup off. All right, so instead of taking the entire bottom off, because that was going to be kind of hard, I think, I just cut a hole in the bottom. It's going to work just fine. All right, next thing I'm going to do is take my balloon, and I'm not going to blow it up or anything. I'm going to tie it. This may also be something you need some grown-up help with. All right, so I've tied my balloon. Then I'm going to cut the end of my balloon off here. Oh, seems like a sad thing to do to a balloon, right? All right, it's tied at the bottom, balloon right here. This means now I can cover the bottom of my cup with my balloon. Let me demonstrate. Or your balloon's going to go flying if you don't duct tape it. So what I'm going to do is pull off a piece of duct tape. Now some people need scissors for this part, but not the science lady. Just rip. It's the easiest thing about duct tape. Practice that. All right, so let's take our piece of tape and we're going to put it around our cup. Okay, that's going to hold your balloon in place. Now you have a completed ping pong popper. If you put your ping pong ball inside, pull your balloon down, your ping pong is going to fly through the air. So much fun. So when your ping pong ball is sitting inside of your cup, that is potential energy. When you pull this down, you're storing up energy. And when you let it go, that converts that energy from potential to kinetic or energy in motion when the ping pong ball flies out. Build your own ping pong popper. You won't be disappointed.